85%. That's how often a tendon-driven robotic hand now successfully reorients a novel object it has never touched in laboratory settings, up from around 40% in 2023. That's not a marginal improvement. That's a field crossing a threshold. That leap didn't come primarily from better hardware. It came from a stranger idea. Deliberately build the hand with fewer motors than it has moving joints, and train the AI to absorb the mechanical uncertainty rather than fight it. Aaron Dollar's Yale lab helped establish this direction over a decade ago. Strip out actuators, let passive compliance and physics resolve how forces distribute across the fingers. The mechanics became a feature, not a limitation. The missing piece was the intelligence above it. Transformer-based AI policies, the same architecture underlying large language models, were trained in simulation on randomized tendon routing geometries, varied pulley positions, cable stiffness, even simulated mechanical wear. The result, policies that transfer to physical hands whose exact mechanics are uncharacterized. Think of it like a driver trained in simulators that randomly introduced ice, fog, and blown tires, until unpredictable conditions became manageable. The variation in training is what builds robustness, not eliminating the variation. The cost implication is significant. Tendon-driven, under-actuated hands run an estimated 60-75% cheaper than fully actuated equivalents, and hands that once cost $50,000 to $500,000 are approaching $2,000 to $8,000 in recent research demonstrations. The hardware barrier is compressing. Analysts estimate roughly $680 to $890 million per year is now flowing into this specific subdomain. The hand hardware appears to be commoditizing. The AI policy stack is emerging as the defensible asset, and researchers draw a direct parallel to the drone industry circa 2014, where a similar bifurcation preceded DJI's dominance. There's a supply chain risk worth naming. The tactile sensor skins that give these hands their sense of touch run disproportionately through East Asian manufacturing. For defense and critical infrastructure applications, that G